Kubernetes using Kubeadm. So let's get started. Thank you for watching my videos. So now we will plan to let's install two worker nodes and uh, two master nodes and see how it goes. We will be following the documentation from Kubernetes.io website and whatever issues we face, we will try to resolve there and then. So I have installed one master node. This is a CentOS Stream 9, which I have installed, and we will be trying to install uh, the master and the worker setup on the same node. So, okay, let's follow the documentation. So this is the documentation that I'm following using the cube variant that we want to do the setup. We need 2 GB of RAM, okay, two CPUs, which I already have it here. If you see this node, yeah, I given purposely more RAM, more memory, 8 GB, and processor is 2 GB. My disk is 20 GB default. This is the ISO which I used for the setup. Um, and it's not required now, but it's okay. So I'm using a NAT adapter. So one of the requirement is that each node needs to definitely communicate with each other, and there should be a default route present. So if you're having multiple interfaces, there should be one adapter which talks to all other nodes, part of the same VLAN or same subnet. So we need to set up a host name now. So let us do that. I already powered on the VM. Okay, just okay. Let me just okay. So we will set the host name. Set host name, and we will give this as KRS master one. Okay, and let us see what IP it has taken. That is basically from the template actually. So it's 149. Okay. And so probably I should be able to take putty now. 149. Yes. So this IP address I got from the NAT network settings, which is there in my VMware workstation. So if I go here, this is the adapter, and I have a local DHCP service running here, which gave the IP address automatically to the server when it got booted. So just close this one. Okay, so we have this node ready, and certain ports are required also. Yes, like Kube API server will need 6443, 8443. Kubelet will need some ports like 10252, 250, 10250, etc. So what I have done is I have disabled the firewall service, okay, at the system boot, so it doesn't get started. So this allows all the communication. So if we cannot stop the firewall service, in that case, we need to open specific ports on the firewall. I've disabled the SE Linux also. Okay, so if we see more documentation, the Kubeadm installation is done via binaries that use dynamic linking. Okay, okay. Yes, Alpine Linux will not use glibc. It's a different distribution. So, mhm. Now it says we need to make sure of our kernel version, and the Kubeadm project supports long-term um, uh, systems kernel. So let us see what is okay. These are the LTS versions. So if I see mine, uname minus R, now this is 5.14 here, and as we can see, it doesn't support 5.14. However, I just gave a try with the setup of Kubeadm, and it gives a warning. However, it still works. So where this affects is there are certain, as we know, during the setup it will use uh, sysctl or sysctl to provide some runtime values uh, to the API server, and those certain values depends on the kernel versions or what is supported and what is not supported like that. So it does not mean that it will not do an installation. Yeah, but if certain critical aspect is required and if that is not supported, it will fail. So however, I have tested this with 5.14, and so far I could not see any problems and it was working. It gives a warning during the setup, however, it still works. So this is about the kernel versions. Okay. And let me just open this one, Linux kernel version requirements. Okay. Yeah, as I mentioned, sysctls, it calls the sysctls. So some sysctls are only available if we have a modern enough kernel, and that's how that impacts the kubeadm to perform some operations when it is trying to um, run some sysctl command to achieve runtime execution. So this is the minimum version that supports kubeproxy, okay, version 2 C groups, like C group version 1, Kubernetes version C group V2 is recommended, okay. CPU stat file was added. So that's how it impacts actually. Okay, so here it tells us that we need to install three components for the setup to run for sure. So there will be a kubelet. Um, we will install kubelet. We will install kubeadm, and we will be installing a CNI container network interface plugin. So kubeadm, we will use it. So it will actually initialize our cluster. And also Kubeadm is like an administrator, so it will also help us to perform admin tasks, to get the tokens or to join another node as part of the cluster. And it has a lot of other commands. So these are the basics ones which I have tried. And Kubeadm basically has a nice help, and we can see all that details over there. Kubelet, of course, Kubelet is the agent we can consider, which is installed on all the nodes, because master nodes will also run some pods as control plane, because it's a control plane. It has some management level of pods, and all the instructions from the API server are taken by the are given to the kubelet, and then kubelet does the rest of the orchestration of spinning the pod or uh, deleting the pods, or for example, if you want to scale a replica set or create a deployment, create a service, ingress, etc., all the other objects. So kubelet is the one which performs that operation. Okay, yes, it performs a pre-flight check. Now it says here if the required kernel version is not supported, so the LTS that we saw here, if what we are using is not supported, it must have failed. But I have already tested this, it did not fail here. So yeah, and yes, this is important. So We make sure that our product is unique with a unique identifier. So our operating system, uh, and we should have the MAC address. Okay. About the network adapters, as we mentioned earlier, if we have more than one network adapter, the Kubernetes components or the control planes or all the nodes should be reachable on the default route. Yeah. Required ports. These required port needs to be open. So 6443 is going to use as default for API. Let us do one thing. I will take a duplicate session and okay. And let me just run this command here. So if I run this, so basically Netcat is checking on the loopback address if 6443 is listening or not. And it says connection is refused. However, we can also make sure using the netcat minus L minus P and we do a 6443. So we are asking it to listen on 6443. Okay. And when I do this again, let me just take, okay. And see, it told me that it was able to connect to 6443 because I was running a netcat here. And so this is how we can verify. Now, if I again do this, because the process is already terminated, it should give me connection refuse. So this way we can make sure if the port is free or not. So the pod network plugin, yes, we are going to use, we have disabled the firewall, so uh, we don't have to worry about the ports that the network plugin will use. Yes, we will be using Calico for the as a network plugin, and if we have to keep enable the firewall, in that case, we have to see the documentation of that plugin vendor who is providing the plugin, what all ports needs to be open. Okay, so Kubelet has this requirement. As I said, we are going to install Kubeadm, Kubelet, okay, and the CNI. So Kubelet has a requirement that the swap should be off. And if you want to tolerate it, that means if you want to keep it on, the kubelet configuration, we can pass this fail swap on to be false. So, but still, if we make this false, the node will not be able to access the swap. So better we stop the swap. Okay, we remove it from the FS tab, file system table, and also okay, this is my swap partition, which I'm going to make it off, and we can run, if you see here, free minus m will show me the swap over here. Here you can see. So let me just do a swap of minus a and run again here. So, okay, it's not utilizing any swap now, and I also disabled it from my FS tab. So after the reboot, it doesn't come back automatically. So, okay. Now installing a container runtime. So of course, we need a container runtime. So basically, Kubelet will need for on all the nodes we need a container runtime. So container runtime is like Docker or um, cryo container runtime or container D, etc. We will be using container D as our container runtime. So it says like its main task, Kubernetes main task when it spins a container, it needs a container runtime to actually run the containers. So, and it uses a CRI to interface with the chosen container runtime. So how it goes is we have Kubernetes and Kubernetes needs a CRI, which is container runtime interface. And that interface talks to our container runtime, which is in this case, we will be using container D. So container runtime is an interface which is gluing the Kubernetes and the container runtime. So it needs, Kubernetes needs a CRI. Okay, and so Kubeadm knows how to scan the list of container runtimes because it keeps a track of the endpoints that it has. So That's how, if you don't specify which container runtime we are using, it will try to scan from here. So these are the endpoints of the sockets, Unix domain sockets, where it will try to search. And so once we install this, automatically is present, and it will try to, even if you don't specify in the Kubeadm, it knows it has to take, it will scan, and whatever it gets, it will try to use that. However, if we are having two container runtimes on the same machine, here it's mentioned that if multiple or no runtimes are detected, it will fail. It will throw an error. So we need to make sure we are using only one. Okay. So let us do one thing. Let us start our setup with container D. Okay. Let me see where is the step. Okay. Let's go with this one. Container runtime. Okay. Okay. So container runtime has some prerequisites again before installation of container runtime. Okay. We have to enable the IPv4 packet forwarding. So if we see right now, like if I do a sysctl, okay, um, and if I just so I grep IPv4, okay, that's a big list. Let me just do SI forward. Okay, so if we see here, net IPv4 forward is 0. This should not be the case. So we need to make sure this has to be 1 because we need IPv4 forwarding to be enabled and not disabled. So there are multiple ways we can do this. We can either copy directly this cat file, okay, and so this will basically create a new sysctl um, conf file for Kubernetes in sysctl.d directory. And if we do a grep again, now we should be able to see because we have to do one more command. Sorry, has to be sysctl minus minus system. Okay, so here you can see now we got this value as 1. So that's kind of like it was able to read our KTS .conf file and it got the new value. If I do a grep now, should be able to see it as 1. So we don't have to reboot the system. This is one of the prerequisites. Now we need a C group driver actually. So C groups are basically control groups, and um, Linux uses control groups. They are basically they enforce the resources which are required by the process. So, and that's how um, Kubernetes needs control group drivers as an interface to control groups, which requests the kernel to fulfill the requirements. So, control groups are required by kubelet, yes, and the container runtime as well. So, container D as well as kubelet both will need the control group uh, drivers, and because they will interface with the control groups to enforce the resource management. Okay, such as the CPU and the memory request, etc. So there are two types of drivers, C group FS and systemd. Our system is initialized using systemd, and it is recommended that if it is systemd, we should use systemd as the C group driver and not C group FS. There are details provided here. This gives a very good information of why and how. Okay, so we can just follow that. Okay, so basically I'm right now looking for, so as part of prereqs, okay, this is fine. However, I'm looking for the, yeah, okay, container D. So this is the setup for container D, and we are going to start with that. So as prerequisites, we have the hostname setup, we have the default gateway reachable, and we have the net IPv4 forward enabled. Yes. So let me open this URL. Okay, so that URL has brought me to this GitHub page for containerd, and it says that okay, known as x86-64 and ARM. So my processor is x86-64. I'm going to use for that. Also, containerd, if we install, we need the CNI plugins and we need the runc. So runc is basically which the containerd is going to talk to, which will then talk to the kernel for the resource allocation. So let us download the containerd version from here. Okay, this is a pre-patch version. Okay. Okay, this is also a pre-patch. So beta. Again beta. Okay, let me just see. Containerd 2.1.4. Let me see where I can get the setup file. Okay, this is what the details about what is the change in this version, and this is the file recommended dynamic in glibc. Okay, here it is. AMD64. So I will take this link. Okay, let us go to the server. I will copy all the setup here in /opt. We'll do a wget. Okay, once downloaded, let us see. We'll follow we will verify the SHA some value. So I just put this one here, and then let me do an SHA 256 sum and the file name. Okay. 0.4. Okay, okay, fine. Let's follow the documentation now. So we have downloaded this, and it says that we need to extract under /user local. Okay, so I'm going to follow this command. Oh, okay. I'm sorry. The version is different. Okay, it has extracted this in bin. So since my bin is in the path already, if I run containerd, okay, -h, okay, and -v should be able to give me version 2.14. Yes, okay. So that is the containerd we have now. So containerd it's built dynamically for glibc. Okay, for Ubuntu. May not work is yeah, this one is Alpine Linux. Yeah, it will not work for that. For that, they say we have to compile it and from the source and then install it. Okay, somebody who's using Alpine Linux. Do I need to download CNI versions? No, CRI feature has already been included in this. Okay, fine. If you intend to start, yes, we will be starting this as our systemd service. So we have to, okay. So we have to download this service for containerd. So let us download that service. Okay, once downloaded, we need to put this in user local lib systemd. Okay, container d dot service, and let us put that in this path, which is slash usr local lib. Okay, systemd, usr local lib systemd. Okay, so it seems there is no systemd in that given path. Let me do one thing. I will just find. So since it was a library, let us try to get user local lib systemd. So if I see this one, okay, it's not. Maybe it should be, in this case, it should be this one. Yes, inside of system, we should be able to see all the multi-user target, all the targets. Okay, so this is the path actually, user lib systemd system in CentOS Streamline, where we need to copy our container file, which is in slash opt in the current directory. Okay, I'll go back to slash opt. And then, okay, we can do one thing. We can just open that file once and see container d.service. Okay, so this is the service. Okay, okay, and since we added the service, a new service there, we will do a system-cuttle daemon reload, and we will enable during the system boot and also start it now. Okay, so we do a system-cuttle status container D, it should be active. Okay, so our first prereq is done for the setup, which is the container D. Container D has prerequisites, as we saw before. It needs a runc, okay, and a CNI. Okay, let's go to this GitHub release and download the runc file. This is a pre-patch. Okay, let's ignore that. Basically, that is for the testing actually. It's a second patch release 3.2. Okay, let us take this one. Runc AMD64. So I'm going to copy the link and we will be in OPT. Okay, the file is downloaded SHA256 and we check on runc. Nine one six three five two one. Okay, FF4EB112A3060AC 5680A0H71E3531269C2D. Okay, fine. And run C is downloaded. Let me just follow the documentation. I'll be closing this and this. Okay, and what we are doing here in this command is we are just copying. So install command will basically copy by giving this uh, permission 755 to this, and we are copying here user local sbin. Okay, let me just copy this first, and it says in slash usr local sbin, and the file name will be only runc. Okay, so okay, if I do a runc now, it should be available on my path. Okay, good. And CNI plugins, container network interface. So let us go and download. So this is a CNI plugin. Okay. version 1.8, and it's the latest one. So we can download CNI plugin AMD64, this one. Okay. So we do a wget. Okay. Okay. And let me just close this, go to document again. It says to create this directory. Okay. Let us create this directory, optcni bin, and we will be extracting. Okay, the version will be different, so I'm going to put my file name CNI plugins. So we are extracting the new tar zip file that we downloaded to optcni bin, the folder which we created. Okay, fine. So we have the CNI and we have the run C and we have the container D. So now there are a few other steps if we are doing directly from DNF, or we are, so all these things we could have done directly from DNF, not this way. So there are steps from that as an option 2 here in the same Git page. From source, we have to compile and build it. Yes, for Windows, there is another separate method here. If you're running your setup on Windows, so we are doing on Linux. Okay. There is a cry.ctl also. Container D has CTR. Okay, it's native. Let me just check. Okay, yes, it has CTR. No, this is the command line interface for interacting with our container D. Okay, now setting up the container D for Kubernetes. Okay, container D has built-in support for Kubernetes CRI, container runtime interface. Okay. Okay, for non-managed environments, let us, okay, ours is a non-managed environment. Let me just open this. So, okay, we have to install container runtime on each node. Okay, okay. So yes, our latest will be Kubernetes 1.34, and we will be following the steps for Kubernetes. Okay, so as we mentioned, we have Kubernetes, then we have the CRI, which talks to the container runtime. So it's important that we should be aligned with what that you use a runtime that conforms with the CRI. Okay, so probably the version needs to be same for the CRI and the CR. So, okay, okay, this we have already done this. C group drivers. Okay, okay, yes. So this is where we have to tell our container runtime that we have that which C group driver it needs to use. Okay, and we will be using systemd as our C group driver. So now it will be using a file called config.toml. So I think by default this will not be there, and we will have to create this one, generate it, I mean. So if I do a list, it should not be present. Okay, so let me just create a directory in HC as container D. Okay, and this command we can use to generate the, yeah, default file. Okay, and we will write in HC container D and config.toml file. Now if we go to this file which got generated, here, this is the default configuration file which the containerd unit will be reading when it starts. So we need to instruct our containerd to use systemd as our uh, C group driver. So our containerd version, as we saw, it's 2.14. We can check once more. So there you go. It is 2.14. And let us do one thing. So we need to search for this plugin, which is CRI v1 runtime and runc. Okay. And in that runc plugin, we need to see for runc options. So let us open that file. Okay. And search for runc. So, okay. This is the default runtime. That is correct. Container D will be having runc. We have already installed it. This is runc and here is runc options. Okay. So here we can add anywhere, and we will be just adding this line system C group true. Okay. We copy and paste. So here we are instructing that kindly use the C group drivers as systemd and not C group FS. Okay. And since we have done a config change, we have to do a restart for containerd. Okay, if any syntax problem is there, it will not start actually. Just check the status and okay, it's fine. So yeah, so that's the containerd configuration which was required. Okay. For cryo, there is another section. If you're using a C group driver, there's another section. So depends. So this documentation has steps for what are the different methods that we are trying to use. Yeah. Okay. So we have the container runtime installed. Uh, we can now install a network plugin. Okay. Let us see the steps for that. Or we can directly, the most common container runtimes use the CNI plugins to manage the network and security, which we have already installed it. Okay. So we already installed the CNI. So we can directly go for okay, and let us see the Calico. Where is the not operations? Yeah, okay. Hmm. So this is what we can. This is the Calico project. Okay, and we need this. We will be downloading the zip. Okay, I don't have Git installed here, so master.zip. Okay, and we can just keep this here as of now because we don't need this now. And let us go with installing the kubectl, Kubeadm, and kubelet. So for that, we need the repo for Kubernetes. So, okay, I think I need to put installing Kubeadm kubelet. Okay, fine. So we have the container runtime. Yes. Ah, okay. It was in the same. So Kubeadm will be bootstrapping the cluster as we discussed. Kubelet is that runs on all the machines in your cluster. Does the same things like starting pods and containers. And kubectl is like we will be able to communicate with the cluster. So authentication method is certificates. Kubeadm will not install or manage kubelet or kubectl. It is managed. They match the version of Kubernetes control plane you want Kubeadm to install for you. Okay. If there is any version skew, there will be problems and the behavior will not be good. It will be a buggy behavior. One minor version skew between the kubelet and the control plane is supported. Okay. Kubelet and the control plane. Okay. So our API is 1.34 and one minor version skew between the kubelet and this could be supported. So it says example is if kubelet is running 1.7 should be fully compatible with 1.8 API servers. If we have 1.34 as API server, 1.33 SKU is fine. Okay. Okay, let us do an installation. Ours is we will follow the Red Hat base. Okay. We have disabled the SE Linux and okay, so this step we are going to skip. Okay. And this is the Kubernetes repo which we are looking for. We will just copy this. So basically it will create a file here in cd etc yum.repos.d. You can see kubernetes.repo. It is enabled by default. And if you do a DNF repo list, it's one command, you can see Kubernetes repo is there. Now we can install directly from the repo and we will do disable exclude as it's mentioned in the documentation. That means when you are updating it, because version, there is a version dependency, skew can result in buggy behaviors, and that's why we disable excludes Kubernetes so it doesn't update it. Okay, so we will install this. This will install kubelet, kubeadm, and kubectl on the node. Okay, it won't take much time for this setup. And this depends on the internet speed connectivity that we have. Okay, the keys are imported and it is installing now. Yeah, kubelet. So if we got all the versions as 1.34. Kubeadm, as we can see here, Kubeadm, kubectl, and kubelet. However, yes, we can follow the document when we are running in a production setup or when we want to upgrade a Kubernetes cluster. We need to be sure of what the API server that we are trying to upgrade, and if we're having a kubectl binary which doesn't support, we will not be able to communicate with the cluster. So such facts have to be considered when we're performing an upgrade, and it has to be done accordingly, following this documentation. Okay. Now kubelet will be running as a systemd, and uh, So we have to enable this on system boot, and we also need to start this. Okay, so systemctl enable, and if we do the status now, so kubelet will be on activating will be in activating state, because it will be waiting for the Kubeadm to get instructions from when we will do the Kubeadm init just in a few moments. So kubelet, it will keep restarting as it says here. So yeah, and C group driver. Okay, I think we already did this C group driver part. Yeah. Yes, we informed our. So here we now C group driver is required by the kubelet, as well as it is needed by the container D. In our setup, we already did the config addition in the toml file of the container D, where we uh, instructed that use the system D as your C group driver. So that is done. However, for kubelet, it says here that by default, kubelet uses systemd. So we don't have to explicitly do that uh, for kubelet. So we can skip that step, and that will be okay. Okay, and so we have the prerequisites set up, and now we also have the required binaries. See, if you see kubeadm, kubectl, and kubelet. Kubelet is already waiting for some instructions from Kubeadm. It's time that we can initialize our cluster now. So, and there is a way that we can do now. Kubeadm, if you see, it has, if you do a help, it has a lot of commands actually. So we will be using init for sure now, because we are going to init. Okay, and join certs. Okay, we will init Kubeadm. So let us do a Kubeadm init minus h. So we have to give a cider for our pods. Okay. So we can also give a cider for the service. So I'm not giving any cider for the service as of now. So pod network cider we will give. Okay. Along with the init command, and Kubernetes version image repo we can also ignore the pre-flight errors. Okay. Because it will do a check when we are running. See, API bind server port. If you don't want to use a default port 6443, so we can use another port here. Okay. So, okay, let us take this pod network cider and do a Kubeadm init cider. Okay. So we need to give a subnet 172.24.16.0/24. I'm giving. This is for the pod network. And we can also give a Kubeadm config.yaml. This is by default it knows how to take that, but this is during the minimal upgrades that we are performing. So we will not be the file is stored here where lib kubelet config.yaml. Okay, so let me just run this and see what. See, it gave us our yes, this is 5.x series. 5.14 is not there. Yeah, it gave us a warning. It's mentioned that it might fail, but let's see if it fails. I'm not sure. Now it is actually pulling the images uh, which are required for the control plane to run, to be up and running. So this task can be done beforehand also as instructed here. Okay. Okay. So this is the gateway. Okay. Okay. We missed one critical step. Okay. I have a duplicate session. We should always use name resolution. So to 168.109.149 and master 1. Okay, let's see how this works now. If we are able to get a successful installation. Yeah. Okay, certificate and key. HCD, it needs an HCD. Yes, that's a database key value pair that API server has. So it's only the API server that will be communicating with the HCD. There will be a controller manager. There will be HCD. These are the components. Okay, great. So the control plane got initialized successfully here. We can see the message and it says to start using your cluster, you need to run the following as regular user. So, okay, let us run this. So the cluster installation got successful. Our kernel version was 5.14, but doesn't impact the installation for Kubeadm. But yes, this scuttle commands that Kubeadm needs, and if that is not part of that, it might fail. Then we are actually copying this admin.conf file in .kube directory. So when we will be running the kubectl commands, that kubectl commands by default it will try to read the config from this uh, home directory of the user .kube folder. It will try to read this config and we give the ownership to the current user. So there are other ways we can export the config file. Okay, we can do this also. That will be fine. This, if you want to join any other number of worker nodes, we can simply run this command. So let me just pull this in, paste it. It is possible to get this string again, but I'm just pasting it. Okay, now it says that our one step is pending. We need to apply this pod network.yaml file. Okay, and so we could have gone from here and then we could have gone the network add-on. There are lots of add-ons, Cisco ACI. Then what we downloaded is Calico, there is Flannel, etc. So we already have this in /opt. Okay, I'm going to take this and did I save this as full here? Okay. And if I go back to /opt, I think we downloaded as a master file. Okay. So just unzip. Okay. So it will unzip in this Calico master. And if you see, there should be a folder manifest. Okay, so manifest is where all the YAML files will be there. Okay, so and we should be looking for calico.yaml. So now since we added this we have our config file ready, we should be able to use kubectl command and talk to our Kubernetes cluster. So if I do a get namespace, as I can see, by default, I get this namespace, kube system, kube public, node lease, default. Okay. So now my kubectl, because of the config that I have here, is able to talk to my cluster. So I have the client certificate data, the client key. Okay. And this is my endpoint or the server IP address where my API is listening on 6443. So that's the reason I was able to run the kubectl command. And because of that, now what we will do is we will go back to cd/opt and we will go to Calico master and manifest, and here we will run a kubectl command. Okay, create -f calico.yaml. So this will install the rest of the network pods that are required for our networking to function. So the prerequisites for this is our cluster should be up and running. So we can then, and so it creates a cluster role bindings, it creates a custom resource code, service accounts, and config maps and deployments, daemon sets. So if you do a kubectl get deploy, okay. So here we got a core DNS in kube system, and Calico is running also in kube system. Yeah. If you do a kubectl get pods, so I think by default it will use the default namespace. If I do -- all namespaces, yeah, these are the pods that are running, like API server, kube controller manager. We have the kube scheduler, which is responsibility to schedule the pods and gives the instructions to the kubelet, which is running. And if we see now the status of the kubelet service, and now it should be up and running. It was in waiting stage because it was waiting from Kubeadm to receive the instructions. So Calico pods are running etcd, the important. So if these pods goes down, our Kubernetes cluster fails to do the required work that it is supposed to do. So if you see, yeah. So yes, guys. So this is the part of this video, and in the next video we will install one more master node, and we will join that node as part of the same cluster that we created just now. After that, we will proceed with installation of worker nodes. I hope you enjoyed watching this video and this video was useful to you. Thank you for watching and hope to see you in next video soon. Thank you.